Welcome back. In the last video, we developed this project concept, and I've implemented a couple of things off screen. So now when we start the application, we can give it an argument, and it will try to load that file if it exists. If it doesn't exist, it will create a new project. There's also some buttons for doing this, but I think this is the most convenient way. So it's more or less feature complete. And another thing is that when we quit, we also try to automatically save, which is quite convenient. But now the application is basically feature complete, so I thought we try to use it for something. And let's go. So let's make a project called Mandelbrot. I'm going to run it in release new mode because why not? So I haven't done that before, so it has to compile everything. Whatever. All right, so now we have that up and running. What we can do is put it over here, take our editor, and now we have a new share here called mandelbrot.glsl. And actually we should probably, we don't need that, that's right. So here we have the basic shader that gives you what you see on the right, and we can change it. We can say 1 here, and it changes automatically. Now, what I want to do is try to make an image of the Mandelbrot set. So let's try that. So this position we get in, position goes from -1 to 1 in both x and y. So let's actually scale it. Let's scale it. Maybe we'll call it just C, or we'll call it Z, I think. I actually don't remember. Let's call it C. I don't remember exactly how the Mandelbrot set is calculated, but we'll call it C. So C, and we scale it from to go from -2 to 2, and then we'll have our set starts out as 0. Actually, probably want it to be vector. Values like that. Then we need a maximum number of iterations, which will be 10 for now. And then we need the actual number of iterations that we do. And then we'll say for iter, maybe we can do it like this. Okay, we do some stuff, and then finally we will assign a color based on what the number of iterations we ended up with was. And I think we'll say we want the color to go from maybe 0 to 1. So in here we will just say, we'll make it gray, so all the channels are the same. And we'll do like that. So now it should just be fully white. We'll do another thing because usually well, let's not do it right now. Okay, so what do we need to do? We have here the current value, and we need to iterate that. So the way the Mandelbrot set works is this, we think of it as a complex number. So a complex number has 2 parts. Let's say x1, y1. You multiply it with another complex number, or you can see it just as a weird way to multiply 2 vectors. But anyway, it's defined like this. So the first component becomes this weird mix of those two, and the second component becomes this weird mix. So let's put it on a separate line. this is how you define multiplication of complex numbers. So if you've never heard about complex numbers, just like this is how we multiply a pair of two numbers. We're going to use that for some stuff. We start with the number 0, 0, and then in each iteration we'll say the new set is going to be set times set plus c. And c is this one, which is defined on by where we are on the screen. Okay. So let us say a new x. Well, that's set x times set x minus set y times set y plus cx. And the new y is 2, because we'll have 1 and 2 being the same, so we can just say times 2. Let's see why. And then we'll say set x is new x and set y is new y. And the point is that if this becomes too large, like what does large mean when we have two numbers, but we can calculate like a distance to 0 that is, just do it like this, x squared plus y squared. And if the distance to 0 is greater than or equal to 2 times 2, so if the distance itself is greater than 2, then we break. And let's try to load that. Now you can already see we kind of have this shape. That is kind of cool. So what happens if we increase here the max number of iterations? You see you get some more fine shapes. And it's not so nice, like the view, so we can try to change where we are looking. So maybe we wanted to go from -2 to 1, I think is usually nice. So it has a width of 2 now. That means we want a width of 3. Actually, we have to multiply by 1.5. But then it's this, and then we want to shift it a little bit. So we want to shift it like that, and now it becomes -2 to 1. So yeah, the y component should not be shifted, so maybe we shift it back. Yeah, sorry, cy is equal to that. Okay, it's still a little bit annoying. What if we do this? Okay, that I kind of like better. And the resolution is not great, and it doesn't help if we change this. What if we make it very small again? This actually looks kind of interesting. I kind of like this way of looking at it, but let's try to see if we can get the details. So what's the issue? The issue is probably that the resolution is not high enough. And where do we control that? Maybe it's in the shader actually. Maybe it's in the shader. Let's maximize this so we can see what is going on. And we have a program. I'm not sure it's that thing. Yeah, I think it's actually in me. Because this one has a, well, this one is drawing the image, isn't it? It's kind of a weird feeling when you don't remember your own code. So actually, maybe it was the shader. Let's go to custom painting. Okay, so here we allocate some size, and basically, can I clone this? And then go ahead and say like rect.width set width is equal to rect.width times 2 and raw rect, and the same for the height. So I don't know if this works, and then we use it here. So let's go ahead and close this. All right. So it didn't help. It actually takes up more of the screen, whereas I want a higher resolution. So let's just turn it back, paint call back. Okay, get rid of that. And painter GL. Maybe we can say something here like GL. That is annoying. I'm not sure how to do it. Maybe it cannot be done. So let's not spend too much time on that right now. Let's instead try to maybe just zoom in on some kind of interesting area. So what we kind of want to do is say like center location. Okay, it's some kind of vector. And what if we say somewhere like here, which is like, this should be 0. So minus 1, let's try minus 1/2 and 1/2. So minus 1/2 and 1/2. And then we want like view width. Let's make it quite small. And then we want to, so we have the position. We want to map that into a certain width and location. So how do we do that? Currently it's centered on 0. So maybe we can just do like this. And it has a width of 2. So we can divide by 2, maybe, and then multiply by view width. And this one we don't need. And that was not good enough. Let's try this. Let's go back to here. And what if we say 5? So, right, has to be plus probably. Go up a bit. Maybe a little bit more to the side. And 0. Okay, let's try 5, and let's now try to zoom in. And actually we need to go up just a little bit more, maybe even to 1. Okay, it's very inefficient way. You know what we should add, like a way to react to clicks. But I'm not going to do that right now. So anyway, here we go. Let's zoom in even more. Okay, let's go even further up. I feel like something is wrong with this code. So when position is 0, we're not at the location. That's the problem. This one has to be taken out like that. Okay. This, I think this makes more sense. All right. So that's good. Let's go still a little bit up and a little bit more to the left. Like that. Zoom in. All right, let's try to zoom in even more aggressively and even more. So let's now increase this. Let's see if we get more detail. Okay, great. That's cool. Let's keep it 30 still. And let's zoom out a little bit. And now let's try something. So what is sometimes a nice thing to do is to say, okay, if we reach the maximum, so inside we reach the maximum number of iterations. And let's actually just make that black. Great. That was not supposed to happen. For some reason we never... Let me try to zoom out again. Like this, maybe. Like this. And if we add this back in, that is strange. What if we make it 100? Still not. If we just say 2. What if we say, this is very, very strange. So we go here, we increase the number of iterations, but we do break out when we go too far away. And some points start at 0 clearly because they're just black, and all the rest they reach the maximum number of iterations. And why is that? So we update it here. I think I just realized something. What if this division is integer division? Right, so it doesn't work. Maybe like that. There we go. Now it looks so much better. Okay, this is super cool. Okay, so now we can actually try this where we set the inside of the set to 0. Like that. Actually, not sure if I like it, but okay, let's keep it. Let's try to zoom into that other location now. Here. Very cool. Let's increase the number of iterations for fun. And also very cool. So we really need a feature to capture a screenshot, but I don't really know how to do that. So what else? I think it's gonna be it for this video. Now we have this super cool program, I think. that automatically reloads the shader, and we can like really easily play around with it. We could, for example, like let's say we make this one a uniform like that. Then we can say, okay, we actually want to control the uniform max iter. It's an integer, and it can go from 0 to 100. Why not? So we add that, make it 35, see how that looks, make it 16, see how that looks. A little bit easier to change if you have something you know you want to change a lot. So I actually don't mind this a lot. All right, that's going to do it for this video, and I will see you in the next one.